2-1 factoring quadratics. I'm going to take a special case, the x squared plus bx plus c. This is a topic typically in grade 10 math that students run into, where they have to factor things out. So instead of distributing across, you want to be able to factor things out. Now, when you tackle polynomials in general, you are probably familiar with factoring out the factors that are in common to all of the terms. Now, if you've forgotten that, I'll put up a link up above, and it's worth a look before you try this video. Once you know and understand how to factor, which is something common in between different types of terms, then you typically in grade 10 get faced with this problem of factoring just quadratics, and they're basically, in this case, trinomial, so they have 3 terms. Now, if you look at x squared plus bx plus c, you will think, well, there's really nothing in common between those 3 terms, so how am I going to be factoring anything out? And let me take the example just below with actually numbers, and I'm going to first kind of refresh you back, and let's say we have x plus 2, and then it's multiplying x plus 3, and you see that I put in some kind of a rectangle in here. And then just for deja vu, so please remember that, you know, what we're doing here is with these quadratics, we're basically multiplying. So this is my x plus 3, and it's going to be multiplying x plus 2, and you can imagine it's almost like we're trying to find an area where we don't know this particular x. Now, if you take that and you multiply those 2 together, those 2, x plus 2 and then x plus 3 together, we can distribute it across. And I can distribute it across, so let me do that next. And that means I'm going to get x times x, which is going to be x squared. I'm going to get plus, now it's going to be 3x. Then I'm going to take the 2, and then the 2 is going to multiply the x. And then finally, I'm going to get 2 times 3, and it's going to give me 6. That's what I'm going to get if I distribute across. Now, typically, once you do that, then you're going to collect like terms, and you see that you have a 3x plus 2x together, which you can get, and it will be 5x, right? And I'm going to do that right here. And that means that this, in simplified form, would have been looking something like this. And if you compare this to our quadratic at the top there, which basically says x squared plus some b, x plus some c, then you can map and do a comparison here. This is your b, your 6 is your c. And our ultimate goal is to be able to take a quadratic, which is a trinomial, which looks like this, and turn it back into this form, which is basically the factored form that returns you back to just multiplication of 2 factors, which is x plus 2 and then x plus 3 as you have there. That's our goal. So we want to kind of go in reverse of the distributive property, and this is called basically factoring quadratics, which are just trinomials, tri for 3. How do we do that? Well, if I take this example, I'm going to try to show you that it's actually not that difficult, but there is a little bit of kind of trial and error as you're going through. Let's think back of what we started with, and that was we had our x, then we had some number, we had another x, and then we had another number. And now, in general, you know, these numbers don't have to be 2, they don't have to be 3, they can be some general numbers. So I'm going to say this is some number x1, and then this is some number x2. And of course, the sign, so the plus can be a minus, that is irrelevant to us. And now, if I wanted to map it back into this form, let's think about, where does this b come from? If I distribute across, where does that b come from? Well, you notice that your b actually is coming simply from the fact that you distributed across, and then you added these two like terms. Now the addition is the addition of these numbers. This is the addition of this number plus this number. In general, what that means that this b right here is just simply the x1 plus the x2. Now in this case, what we had, this was just simply 2 plus the 3 for our case because we knew what x1 and x2 were there. And that gave us 5. And that was right here. That is where our b comes from. Our b is basically, therefore, the addition of those two numbers. Now let's think back and think of, okay, where does c come from? Well, c, because if we go back to the distributive property, our c really is just simply the multiplication of these two numbers. If I erase this back, and now I'm going to highlight it again, this is my 2 and my 3. That c, which is 2 times 3, which is 6, comes from the fact that all we're doing is we're taking the 2 and we're multiplying them together. And again, so for us, this was 2 times 3, which gave us 6. There is no magic, therefore, in setting up these problems. And you can go back from the form of x squared, plus bx plus c, and put it back into the factored form, which looks something that we started with. Now, as I said, it is a little bit of trial and error because you have to think, okay, which two numbers, when I add them together, are going to give me b, and then which two numbers, now they're the same numbers, when I multiply them together, will give me c. And if I took this right here, and somebody gave that to me, then what I would have done is, I would have said, all right, wait a minute. I typically will start first by taking a guess of trying to multiply two numbers to give me 6. And I set this up because what I want is the factored form. So it's going to be x plus or minus something multiplied by x, again, plus or minus something. And now I think to myself, all right, so which two numbers, when I multiply them together, are going to give me 6? Now in grade 10, you typically, when you start this, the numbers are whole numbers or integers. They're not going to give you fractions or decimals, which would make it really difficult for yourself. If you do get into the point where you're dealing with fractions and decimals, which might be a little bit later on in your math career, you can still use this method, but then you probably are going to be using other methods, which you're going to be learning in future videos and in different courses as well. For now, we're going to just stick to integers. So which two integers, when I multiply them together, are going to give me 6? And let's just take a look. So 1 times 6 is going to give me 6. And of course, we know that 2 times 3 is going to give me 6. And now if I take any other integers and I multiply them together, they won't really give me 6 unless I start going with fractions or something or decimals. Now, if this was your first choice, 1 times 6, then don't forget that now you go back and you check for yourself when you're doing this. When you add them together, they're supposed to be giving you b back. But b in this case was 5. If I take 1 times 6 and I add them together, that's going to give me 7, which is not 5, which means that this guess was incorrect. And therefore I can move over to the second guess. And if I take 2 times 3, which is 6, so that is indeed my c, then I can check, well, 2 plus 3 does give me 5. And there you go, I have found my two numbers that will make this true. Now finally, once you do this, you can still do a check, and then you can use the distributive property, distribute across, just to double check if you do indeed get this back. But basically what you're doing is you're going to take, okay, 2, 3, well 2 plus 3 is 5, that's good, and 2 times 3 is 6, and there you have it. I found my B and I found my C. That's what you do in these examples. And now it is in factored form. There are two factors here. Here's your first factor, here's your second factor, and then you can stop. So it's a little bit of a puzzle that you're solving. Let's take a look at some examples of how this can be applied. I have x squared plus 3x minus 18. And again, what I want is I'm going to take now, notice I take 18, but it is negative. What I am looking for, therefore, is I want two numbers that give me 18. Now I can think of the numbers. All right, well, again, start with integers or whole numbers because that's what you kind of want. Well, 1 times 18. Now, if I do that, of course, notice that the sign is negative, so one of them has to be negative, either the 1 or the 18. But if I add those together, that doesn't matter which one is positive, which one is negative, I am not going to get 3 back. Because if I take, negative 1 and then 18, it's going to be 17. So that doesn't give me that back. These two numbers won't work. Then, what others? Well, 2 times 9, I can check. Okay, now does this work? Well, again, one of them has to be negative because of this sign right here. And again, if I add them together, they're not going to give me 3 back. This doesn't work either. And then finally, I can say 3 times 6. That gives me 18, so this looks promising. And now I have to get 3 out of it. If I want 3 out of it, I have to make one of these negative. Well, which one should I make negative? Because now notice that this is positive. So my C is supposed to be negative 18 and my B is supposed to be positive 3. That's what I am looking for. And again, this goes back to this x squared plus bx plus c. That's what these are. If I make 3 negative, therefore I'm going to have negative 3 multiplied by 6. This gives me negative 18. That satisfies my C. Now I'm going to check if I add them together, which means negative 3 plus 6. That gives me 3 back. Oh, that satisfies my B. And therefore I have found my answer to my factored form. It's going to be, here's my x, and now one of them is going to be negative 3, and then the other one is going to be 6. Now you may ask, does it matter? Like for instance, could I have put this? And the answer is, of course you could. The order of the multiplication doesn't matter. What you want is, are these factors what you want? Now, as a check, make sure that you go back and say, all right, so negative 3 plus 6 indeed gives me 3 back. And then finally, negative 3 times 6 gives me negative 18. And that is that in factored form. That's what you actually have to do with these. Now, I have shown this. Once you do several examples, you will much quicker try to be able to see what the answers are. Now, sometimes the number are a little bit annoying that you will have. They might be a little bit bigger, okay? And you may not be able to see them right off the bat. Don't get frustrated and then try to see which ones will work. Okay, so that's this example right there. I'm going to delete this one. Let me go back now to the second example. Now, in our second example, in this one, what we have is our B is equal to plus 13, and our C is equal to plus 36. Now, I always start first, try to find my C. Which two numbers that I can get that are going to give me 36? Which ones pop into my head kind of right away? Well, there are many, right? 1 times 36, 2 times 18. You can do that. You can go then 3 and so on. Now, in this one, I'm kind of peeking and I'm thinking, all right, well, 4 times 9 is going to give me 36. And now notice, if I add them together, the 4 plus the 9, it's going to give me 13. And therefore, that would have been the factored form. I would have had x plus 4, x plus 9 is the factored of that quadratic. And I have found my two numbers to be able to do that. Now, the third example, it has some negatives. I will do those. Delete. Now, this example, I have my b is equal to -6. My c is equal to -7. Again, start always with these, okay, with the c, so that you can multiply and think of which two numbers might give you -7. Now, first I'll think of 7. Well, 7 is a prime number, which means, you know, right away, if I know that it's a prime number, there are no two numbers that go into it except 7 and 1. And therefore, so this one will be rather easy once you notice that it's prime, because 1 times 7 gives you 7. Now, one of them has to be negative. And I look to help me in terms of b. Which one is going to be negative? This is 1 and 7. Well, it's going to be the -7. That has to be negative because when I add these together, so if I add this together, I'm going to get -6. And if I multiply this, I'm going to get -7. And there you have it. You found your two numbers. This would mean that I would have x plus 1, x minus 7. Again, you can check. 1 times -7 is going to give you -7. And then 1 plus -7 is -6. And those are the two that I needed there. The last example that you have here, so this one looks like it's something which is a little bit annoying. B is just +2. C is -143. All right, well, which two numbers is that going to be? Now, it's going to have to be a little bit larger numbers because it's 143. It's not going to be two numbers which are going to be rather small. Now, notice that it is negative here. So one of them has to be negative in order for that to be negative. What does that mean? Okay, well, I can think of some numbers. Well, 143, I'm just thinking of my multiplications. You know, you might struggle with this a little bit if your multiplications aren't maybe, you know, as crisp at the moment. And I can think back, well, this is 11 actually times 13 is 143, right? So 11 times, we will have, I'm going to check this. Now, I don't know if that's the answer yet. 11 and 13 is 143. And the way that I see that is, by the way, just so that you know, because 11 is just 10 plus 1. And 10 times 13 is 130. And then 1 times 13 is 13. So if you add 130 plus 13 is 143. So that's how I saw this. And if I take 11 and 13, and actually notice, because we want to have b to be +2, that means that this -11, if you make that, and then you add these two numbers, -11 plus 13 indeed gives you 2. And there you go. We found our answer. This would have been x plus 13, x minus 11. Again, it doesn't matter the order of these. You can reverse them, but that's what you would have. And that's how you find, and it's the method that you use for these quadratics. In general, so don't forget that your b is always going to be equal to whatever that x1 plus x2 is. That's what your b is. And then your c is always the multiplication of the two numbers, whichever numbers you have. And you can do that. Thanks for watching. We'll see you in a future video. Take care, everybody. Bye.